Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we're going to be talking about basic operations with vectors, right? Okay, so we're going to be talking about basic operations with vectors. Let's go ahead and get started. There we go. Okay, so if you watched the previous video on vectors, you would have known that a vector is something which has a direction as well as a magnitude, isn't it? So a vector is something which has a direction as well as a magnitude. So that means that if I have two vectors, let's suppose I have a vector AB, the magnitude is 5. If I have a vector, let's say CD, and the magnitude is 7, I can't say that AB plus CD is going to be equal to 7 plus 5, that is equal to 12. That will not be true all the time. That might be true some of the time, but not true all the time, because we don't know anything about the directions of the vectors, isn't it? So what we're going to do now here is we're actually going to explain the vector. So before I'm going to do that, I'm actually going to take an example. I'm going to pick up a vector. Let's suppose I'm going to pick up a vector called force. Now force is actually a vector, isn't it? So when you apply a force with a certain magnitude, and you apply force in certain direction. Fine. So you basically apply force in a certain magnitude and you apply force in a certain direction. So I'm actually going to use the example of force here. So let's say, for example, if you have an object right here, right? So let's suppose if you have an object right here, you apply a force in this direction, right? And you apply a force in this direction. So you apply a force in this direction, you apply a force in this direction. Where will your object go? So if let's suppose someone was pulling you from this side and someone was pulling you from this side, you will actually go between both of them, isn't it? So that is going to be your resultant vector. So if I say this is a vector AB, and if I say this is a vector BC, then this is going to be your resultant vector. That is the resultant vector. Resultant vector is the the result of two vectors. So this is going to be a resultant vector. Fine. And so you can say that vector BA plus vector BC is equal to vector, let's say this is point D, BD. Now understand, this is BA, it's like this. This is BC, this is like this. Vector BA would be different from vector AB because of the direction change, isn't it? So this is what we call as the resultant vector. Now what you can say is, you can actually say that BC is equivalent to this vector. Let's say this meets here, right? So my diagram is not on scale. So I can say that vector BC is equal to vector AD, because they have the same magnitude. So this is the same magnitude, and this has the same direction as well. Similarly, I can say that, so let me say that the point C is here. Similarly, I can say that vector CD is equal to vector BA, because they have the same magnitude and the same direction. And what do we have here? This is something which we have is a parallelogram, isn't it? So this is something which is a parallelogram. So you can clearly see that either you can take vector AD or you can take vector BC, because it doesn't matter, because they have the same magnitude and the same direction. Vector AB and vector CD, they have the same magnitude and they have the same direction. So this is something we have. So this is something that we have is called the parallelogram. ABCD is actually a parallelogram where two sides are parallel to each other and equal to each other, and two sides are parallel to each other and equal to each other. As you can see, the resultant of these two vectors is going to be this vector, and resultant of these two vectors is going to be I'm just talking about the resultant of these two vectors is just this vector. Fine. So that's there. So I hope you're able to understand this point over here. Let's actually move forward. Let's say that the point, so you can clearly see here that both the vectors have the same starting point, isn't it? They have the same starting point. What if both the vectors did not have the same starting point, right? Let's say, for example, they had different starting point. Then what you're going to do? So what about different initial point? You can say that different initial point. So let's suppose if I say that there is this vector CD, it's like this is CD. And on the plane, so let me say this is the plane, right? On the same plane, you have another vector, let's say you have another vector AB. Fine, so let's suppose you have another vector AB, and let's say that vector is like this. So AB and CD, they have different starting points, isn't it? Right? So AB and CD, they have different starting points. So what I'm going to do is I'm actually going to consider a new vector which is parallel to CD, and it has the same direction, same magnitude as CD. Let me say this is BE. I'm going to consider a new vector BE which has the same magnitude as CD and same direction as CD. Now that's what it is. Fine. So I hope you're able to understand my point over here. So what we did was we assumed a new vector, let's say assumed a new vector BE which has the same length. So this length and this length is going to be the same, and which has the same direction as this vector. So this is what we have. Now what we're going to do is we're actually going to use the parallelogram rule again. So if you have something being pulled in this direction and something being pulled in this direction, what is going to be the overall direction? So the overall direction is actually going to be this, isn't it? Right? So this is the direction which the object is going to go. If I apply force in this direction, if I apply force in this direction, the overall direction would be this direction. So I can say that vector AB plus vector BE is equal to vector AE. Something that I can also say that vector AB plus vector CD, which is equivalent to BE, is equal to vector AE. So I hope you're able to understand this point over here, guys. Let's move forward. Now let's say, for example, I have these three vectors on the plane, right? So this is the plane. I have these three vectors on the plane, and I want to find the resultant vector. So what I'm going to do is I'm actually going to take this AB here, and let's say AB. So let's say this is AB. I'm actually drawing another plane. So I'm going to assume another vector which is parallel to CD, and exactly the same length as CD. So let's say this is equal to BP. Fine. And then what I'm going to do is I'm going to assume another vector which is parallel to EF, and it has the same magnitude as EF. Let's suppose this is PQ. So this magnitude is equal to this magnitude, and the direction is same. So what is going to be the resultant vector? If something gets pulled like this, and pulled like this, so all you have to do is just join these points. That is vector AQ. So that means I can say that vector AB plus vector CD plus vector EF is equal to vector AQ. So this is what we have as vectors. So this is something which is known as the triangle law. Right. So what we just did here in the previous slide and in this slide, this is something that is known as the triangle law. Okay. Now let me go ahead and talk about some vector properties. That's actually very important. So some of the vector properties are that first of all, if you have two vectors, let's suppose vector U and let's suppose vector V. And let's suppose vector W. Let's suppose you have these three vectors. They have a magnitude and they have a direction. So vectors are something which are commutative. So what do you mean by being commutative? That means U plus V would be equal to V plus U. Fine. Vectors are something which are associative as well. That means U plus V plus W would be equal to U plus V plus W. Right? So either you add these two vectors and add the resultant to this vector, or you add these two vectors and add the resultant to this vector, you're going to get the same result. Fine. And then you have all the vectors have an additive identity as well. That means that there exists a zero vector such that if you add 0 to a vector, or you add 0 like this to a vector, you'll actually get the same vector itself. Fine. And another thing is that you have additive inverse identity that says that every vector has an inverse of itself, additive inverse of itself. So when you add it, you always get a 0. So either you add it this way or you add it this way, you're going to get a 0. Fine. So I hope you're able to understand what I'm trying to say here, guys. Let's just say if I want to prove these properties, let's suppose I want to prove that vectors are commutative, right? So how do I prove? How do I prove that vectors are commutative? So I would say that, let's say we have two vectors. Let's suppose this is vector v, and let's say this is vector u. Okay, so this is vector v and this is vector u. The resultant is actually going to be equal to u plus v. And another thing is that if this is vector u, if I take another vector of the same size, this is going to be vector u. If I take another vector of the same size, this is going to be v. So u plus v gives us, so if I use the triangle law, this is going to be the resultant vector for both of them, isn't it? Right? So that means u plus v will give me the same resultant vector as v plus u. Fine. U plus v is going to give me the same resultant vector as v plus u. So that is something that proves that the vectors are commutative, right? So that's that. Because if something is being pulled in this direction and something is being pulled in this direction, this is the resultant that we get. And if something is being pulled in this direction and in this direction, this is the resultant that you're going to get. And this resultant is going to be the same, isn't it? Right? So yeah, so let's suppose if you're right here and I pull you in this direction and someone is pulling in the right direction, you actually are going to go in this direction. Same goes for if you're right here, someone pulls you in this direction, you're going to go in this direction, and both are going to give you the same value only. Fine. So hope you're getting this, guys. Let's go ahead and talk about the zero vector. So I think we've discussed about zero vector in the previous video as well. What do you mean by zero vector? So if I have, let's suppose, a vector AB, right? So let's suppose this is in the plane. Let's say this is vector AB. Fine. So vector AB, and let's suppose if I talk about vector BA. Now vector AB is going to be the negative of vector BA because they have the same direction. Sorry, they have the same magnitude, but they have different directions. So they have the same magnitude, however, they have different directions. So that means if I add vector AB and if I add vector BA, or if I add vector BA first and then add vector AB, it's actually going to give me 0 because they are negatives of each other. So I hope that's fine as well, guys. So I hope you're able to understand my point here. All right, let's move forward to the next point. Now let's go ahead and talk about the scalar multiplication of vectors. Now what you can do is you can actually multiply a scalar number to vectors. So this is something that you can do. So let's suppose in a plane, if I say this is a plane and I have a vector A, let's suppose this is vector A. So if this is vector A, now first of all, I'm going to show you how do you define the magnitude of it. If this is vector A, the magnitude of A can be represented as the absolute of A, means two, you have two signs next to it. Now, if you find the absolute of a scalar, you actually get the absolute value, but here you just get the magnitude of A, that is the distance of this length, the measurement of this length. So this is something, this is how we represent the magnitude of A. Now if I want to talk about, so this is the magnitude of A. Now if I want to talk about a scalar multiplication, let's suppose I want to find out 3 times A. So 3 times A would have the same direction, it's just that it's going to have 3 times the length. So this is something which is 3 times A. Let's suppose I want to talk about negative 2 times A. So negative 2 times A is going to have the opposite direction and it's going to be twice down. So this is negative 2 times A. So this is what we mean by, this is something what we mean by scalar multiplication. So if you multiply with a negative number, the sign reverses, and if you multiply with a scalar number, then just the length increases by that scalar number. So if I have, let's suppose, again, the scalar multiplication follows some properties, right? So what are those properties? Let's go ahead and talk about that. So the scalar multiplication has the properties of vectors in scalar multiplication. So I'm actually going to assume some vectors, let's say u and v. So I'm sorry, u and v. So you can say that, first of all, the vectors are commutative. Again, you must have understood what commutative is, that if I multiply a scalar with a vector, that is equal to vector into the scalar. So that means 2a is equal to a into 2. Another thing is that vectors are associative, right? That means that if I have, let's say I multiply alpha with beta vector, that will actually be equal to alpha beta vector. Fine. So that means they are associative. That if I multiply one scalar first and another scalar, that is equivalent to multiplying both the scalars together. Fine. So let's say, for example, 4 times 2 times a is actually equal to 8 times a. Something very easy, but something very, very important. Another thing is that the vectors multiplication is distributive. That means I can say that alpha u plus b is actually equal to alpha u plus alpha v. Right? So that means, for example, 2 into u plus v would be equal to 2u plus 2v. You can either multiply 2 individually and then add them, or you can just add them together and then multiply by 2. So this is something that you can do. The next thing over here that I'm going to talk about is that, so that means there is a multiplicative identity as well. So there is a multiplicative identity. That means that if you multiply any vector with 1, you'll actually get the same vector. Fine. Another is the property of 0. That means that if you multiply 0 with a vector, right, you will actually get 0 itself, or you multiply vector with the 0, right? So that's there, guys. So I hope you're able to understand this point over here. So alright guys, thank you very much for watching this video, and I hope you understood about you build your basics on vector algebra, right? So make sure that you solve questions on this so that you actually understand everything about it. So this would be our Facebook page where you can give us your valuable like, this website where you can explore more about us, and this email address where you can give us your valuable feedback. So thank you very much for watching this video, guys, and I'll see you in the next one.